13 billion light-years away, astronomers found a galaxy that is breaking the rules. It's massive, it's ancient, it has more stars than our entire Milky Way, and it isn't spinning. Every galaxy we know is supposed to spin. It's not a suggestion, it's physics. And yet, in May 2026, the James Webb Space Telescope looked at something that formed when the universe was barely a toddler and found a galaxy that should not have had time to become what it already was. Something doesn't add up, and by the end of this video, you'll understand exactly why that terrifies and excites the people who study the sky for a living. To understand why this discovery matters, you need to understand the telescope that made it. The James Webb Space Telescope launched on Christmas Day 2021. It doesn't orbit Earth. It sits nearly 1.5 million kilometers away at a gravitational balance point called L2, where it can stay perfectly still relative to the Sun and Earth. Its mirror is 6.5 meters across, 18 hexagonal segments coated in gold built to catch infrared light. And that matters because infrared light is what very old, very distant objects send us. When light travels billions of years across an expanding universe, it stretches, it shifts toward the red end of the spectrum. So the deeper Webb looks into infrared, the further back in time it's actually seeing. In other words, Webb isn't just a telescope, it's a time machine, and it's been pointed at the earliest chapters of the universe's story. That's exactly where this particular mystery begins. This isn't the first time Webb has made cosmologists nervous. Almost as soon as it started collecting data, astronomers noticed galaxies that existed just 500 to 700 million years after the Big Bang, and they were far too bright, too massive, and too fully formed for their age. According to the standard model of how galaxies grow, slowly pulling gas, igniting stars, merging with neighbors over billions of years, these galaxies simply shouldn't have had enough time to mature. Some researchers proposed that early star formation happened in much more intense bursts than we assumed. Others suggested dark matter played a stronger, faster role in gathering material than current models predict. Nobody fully agreed, and nobody had a clean answer. Then, in 2026, one particular galaxy pushed that mystery even further, because this time, the problem wasn't just how big it was how still it was. Its catalog name is XMM-VID1-2075. It's part of a survey called MAGAZINE, short for Massive Ancient Galaxies at Z greater than 3 near infrared, led by astronomer Ben Forrest at the University of California, Davis. Using the Keck Observatory in Hawaii, Forrest's team had already confirmed something remarkable about this galaxy. It existed when the universe was less than 2 billion years old. It had already contained several times as many stars as the entire Milky Way, and it had already stopped forming new stars. In cosmic terms, it was old before its time. But Keck couldn't tell them how the galaxy was moving inside. For that, they needed Webb. So, in May 2026, the James Webb Space Telescope pointed at XMM-VID1-2075 and two neighboring galaxies from the same era and tracked the motion of material inside each one. One galaxy was rotating normally, another showed a chaotic, irregular structure. But the third, XMM-VID1-2075, showed no organized rotation at all. Its stars weren't circling together in one direction. They were moving randomly, like a swarm rather than a wheel. That kind of motion, astronomers call it a slow rotator, is something we normally only see in enormous ancient elliptical galaxies nearby, galaxies that have had 10 or 12 billion years to collide, merge, and scramble their own momentum into stillness. This galaxy had none of that time. It formed, matured, stopped making stars, and lost its spin, all within less than 2 billion years. This shouldn't be possible yet. Forrest and his team, publishing their findings in the journal Nature Astronomy in May 2026, noticed something else in the data: an excess of light off to one side of the galaxy, a smudge that shouldn't be there. Their leading explanation isn't a slow buildup of many mergers over time, it's a more dramatic, single, violent collision. If two galaxies, each already spinning, collided while rotating in nearly opposite directions, their momentum could cancel almost instantly, leaving behind exactly the kind of motionless, massive remnant Webb had just photographed. Here's why this isn't just a curiosity for astronomers to file away. Our entire model of how galaxies form, how they gather gas, spin up, collide, and evolve is built on timelines. Galaxies are supposed to earn their stillness. They're supposed to need billions of years of cosmic traffic to lose their spin. XMM-VID 1-2075 didn't wait, and the simulations current cosmologists use predict that galaxies like this should be extremely rare in the early universe, if they exist at all. Every one we actually find this early is a data point that pushes back against the models. It's a test the universe is failing to confirm, or a test our theories are failing to pass. And this galaxy isn't alone. Across 2026, Webb has continued finding early universe structures that seem to have skipped steps, galaxies that collided far sooner than expected, clusters that look abnormally well developed for their age, star systems that matured on a timeline the textbooks didn't predict. Individually, each discovery is a puzzle. Together, they're starting to look like a pattern. And patterns are what force scientists to go back and rewrite the rules. We don't yet know if the early universe grew up faster than we thought, or if it built its galaxies through moments of sudden, violent chaos instead of slow, patient growth. What we do know is this: a machine built to look backward in time just handed us a galaxy that doesn't follow the timeline we wrote it for it. Somewhere, less than 2 billion years after everything began, something massive stopped turning, and we are still trying to understand why. If stories like this fascinate you, the moments where the universe quietly contradicts itself, subscribe to NEXORA, because the more we look, the more we find that we've barely scratched the surface.